Hello everybody and welcome to the second episode of the basic OpenGL tutorial series. In this one we're actually gonna be creating our first triangle and drawing it on the screen. So we briefly went over shader programs in the previous episodes and wrote two basic shaders in here. But in this episode we're gonna feed them with some data. So to do this we're gonna have to create a buffer. A buffer is basically an array of unformatted data on the GPU, which basically means that it's just full of just bytes that OpenGL doesn't really know how to use. So we have to specify what the data will actually mean. So if we just try to create a buffer now, we're just gonna create a global buffer ID variable and just gonna create a function that will create our buffer. So now in OpenGL we can create buffers with glgen buffers, and we're just gonna create one buffer at the location of gbufferid. And then we have to bind the buffer to the gl bind buffer to GL array buffer, because this will be a vertex attribute, basically attribute for our vertex shader. So if we just go to the OpenGL specification, you can see different buffer binding targets. So we're just going to be using the GL array buffer in this video, which will be for vertex attributes, as I've said before. But in the future we'll also go over GL element array buffers, which I will explain in probably the next video. So let's just go back to our project. We're gonna bind the gbufferid as a GL array buffer, and then we have to specify the data for our buffer. So I'm just gonna create a vector of floats and just gonna call it data, and here we will pass the 3 points we will require for our 2D triangle. So if I just go to paint, let's say, and I just draw the coordinate system, this will be the x-axis and the y-axis. So if we try to draw a triangle, we have to specify 3 different points. Let's say this point is at -1, 0, and the x and y coordinate, and this one is at 1, 0, and this one is at 0, 1. Then we can just connect them and we get a nice little triangle. In OpenGL you have to basically specify the points in clockwise direction. This will be more relevant in some future tutorials where I will talk more about some optimizations that we can do. But let's just now keep that in our mind, that we have to specify them in the clockwise direction. So we can just now put those 3 points in our vector. So -1 and 0. Should probably make them float, and 0, 1, and 1, 0. Okay, so now that we have our 3 two-dimensional points, we can actually now put them in our buffer. GL buffer data to set the data for our GL array buffer. So the first parameter will be our target. So this is the GL array buffer. The next one will be the size in bytes. So if you just try writing data size of this vector in here, this will actually not work correctly. This will probably just take the first and the first half of the second value. So basically just 6 bytes of data, but one of these numbers is actually 4 bytes of data because we're using floating point numbers. So we have to multiply this by size of float, or to be more flexible, we can just multiply it by the size of the first element. So this will be the size in bytes. The next parameter will actually be the pointer to our data. So we can just type here data.data. In some older versions of C++, you could actually also write the pointer to the first element doesn't really matter, it's basically the same pointer. So the next parameter will be the actual usage of our buffer. So in OpenGL we have 3 different usages for buffers, depending on how much we, depending on the ratio of reading and writing from them. So we will be using GL static draw because we won't really be modifying it in any way in the future. So the other 2 modes are GL dynamic draw, which basically means that we might modify our buffer every few frames, for example, and GL stream draw, which basically signifies that we'll be updating the buffer really frequently, maybe perhaps every frame. But if we're just updating it, let's say every few minutes, we can also write GL static draw for this. So before we actually end the function, it's also highly recommended that we unbind the current bounded buffer. So we can just, let's just copy this and just gonna bind the array buffer to 0, so we don't accidentally bind this buffer in any further functions. So we just unbind it after we create it. Then we're just gonna return the gbuffer ID. This doesn't really make sense because it's actually a global variable, but doesn't really matter because we're just creating a function. Actually, let's just create a local variable in here. So we're just gonna call it buffer ID, and we're actually just gonna replace all of these globals. Okay, so now we have an actual function. We will be probably passing the data as an argument later on for this when we're gonna be loading some models and such, and we're gonna need some custom data. So now that we have our create buffer function, we can actually go to our init function to create our buffer, and we're just gonna set the gbuffer ID to create a new buffer. And now that we have this, we can actually go on and draw our triangle. Before we do that, we're actually gonna go to our Vertex shader and add the data we're gonna be receiving. So we can do this with an in, and this will be an input variable to our Vertex shader. So that's why in, and we'll be receiving 2-dimensional data, so vector2, and just gonna name it, let's say Vertex, Vertex, and just gonna paste this in the position. So now that we have this, we can create a function for our draw triangle. So I'm just gonna go about display and gonna call it draw triangle, and in here we're gonna first use our shader program. So we do this with GLUse program, program ID, and before I forget, I should also unbind it when the function will close. So use program, and then we have to bind our buffer again to GL bind buffer, and again we're just gonna be using the array buffer binding and the gbuffer ID. And before again I forget, I will unbind this at the end. Okay, so now that we have those 2 things, we then have to get the location of our variable in our Vertex shader source. So this will be an unsigned integer, Vertex, no, I'm just gonna call it ID, and we do this with GL get trib location, and we pass in the program ID and the name of our variable, which is Vertex. Now we have to enable the Vertex attribute array. We do this with GL enable Vertex attrib array, and we're just gonna pass in the ID. Then we have to specify the what kind of data we're gonna be sampling from our buffer. So we do this with GL Vertex attrib pointer. Yes, and again the index will be the ID, the size will be this time in floats, So 2 floating point numbers, basically 2 dimensions, and the type will be GL float. The next parameter will be the boolean if we want to normalize our data, which you almost never want to do, especially not where we're dealing with points. So just pass in GL false. The next one will be stride, which I will talk about in the next tutorial probably, but we can just pass in 0 in here, and also the pointer can be 0. Okay, so now that we have everything set up, we can actually make a draw call to draw our triangle. So we do this with GL draw arrays, because we'll be drawing directly from a data array. And we will be drawing GL triangles, because we will be using 3 different points. So GL triangles, and the first ID will be triangles, yes, triangles, okay, and the count will be 3 because we'll be drawing with 3 different points. Okay, now that we have our draw triangle function, we can just call it in our display function. So draw triangle, and if I haven't, and before I forget, I should also disable the vertex attrib array at the end. So GL disable vertex attrib array, and with the same ID. Okay, so if we try to run this, you can see we get a triangle, yay. So actually it looks a bit stretched because we have no perspective yet, and our screen coordinate system is bound by a box of -1 to 1 in x and epsilon, x and y direction. So we can now just go back to the data, and let's just make the triangle a bit narrower. So if we try to run this, this should be 0.5, okay. So now we get a nicer triangle. If we can now, instead of getting the attribute location every time we draw the triangle, we can actually hard code it in our vertex shader. So firstly, we'll have to specify, this is only available for versions of OpenGL of 3.3 and above. So we firstly have to specify which version of the shader we'll be using. So we can do this with version 330. So this will, and just gonna make it core, and this basically means we'll be using the 3.3 version of the GLSL, and we can then use the functionality that is required for hard coding the actual IDs in the shader for this, so we don't have to call GL get attrib location every frame. So I'm just gonna make a new line here, just gonna go in new line. Okay, now we have this, and then we can type layout location equals to 0, and instead of getting the attrib location, this ID will always be 0. So now I can just type in 0 instead of ID, and I can just delete this line in here. So if I try to run this again, everything should be the same, besides the attrib location every frame, getting the attrib location every frame. So now that we have this, we can actually try drawing a quad this time. So if we just go back to Paint, if we draw the coordinate system again, the X and Y, this time we'll be dealing with 4 different points. But graphics cards aren't really optimized to draw quads, so we'll be using 2 different triangles to draw this. So if we just draw 2 different triangles, and if we write out the points, so this will be -1, 1, and this will be -1, -1. This will be +1, -1, and this will be 1, 1. Okay, so now that we have our 4 points, I'll actually make them 0.5 because if we, as I stated before, the screen coordinate system is actually bound between -1 and 1 in both directions. So if we just tried drawing a quad like this, it will cover the entire screen. So instead of 1, I'm just going to be writing 0.5. So if we just go up here, we'll be again going in the clockwise direction. So this one in here and like so. So if we just start with -1, 1, -1, -1, we'll, instead of 1, we're gonna be using 0.5, so -0.5, -0.5, the next will be -1, 1, so like so, I mean, like so, and the last one will be 1, -1, so just gonna turn those around, and we have our first triangle. The next one will be this one, so we're just gonna start with 1, -1, again with the same as before, and then -1, 1. Can just copy this one, and finally we can write 0.5, 0.5. Okay, so now that we have our two triangles, everything should be working just fine. Now, before we actually try to compile this, we have to change the number of points from 3 to 6, and if we try to run this, we get our quad from two different triangles. So now that we've done this, we're going to be trying to optimize the rendering a bit. So we can, instead of writing out 6 different points, we can just write the 4 points that we've specified in here. And if we just write another, now let's just comment this out, and we're gonna be we're just gonna be deleting the middle two. Okay, so now that we have all our 4 points, we've created our vertex buffer, and now we will actually create a buffer that will specify which points from this buffer we're gonna be using. So as I mentioned before, there are multiple types of buffers, and for this one we're just going to create an index buffer. Create index buffer, which will basically use this the points from this buffer with the indices from another buffer. So if the index would be 1, we'll be using the first point, and if it would be 2, for example, we'd be using the third point. So we can just copy the buffer creation from here to here, and instead of floats, we're gonna be using unsigned integers. So unsigned int, and in here we're gonna write down the indices for our points. So let's say this will be the 0th index, the first, second, and third. So the first triangle will be 0, 1, 2, so 0, 1, 2, and the second one will be 2, 1, 3, so 2, 1, 3. So we can just write those indices in this vector now, 0, 1, 2, and 2, 1, 3, I believe, yes. And instead of GL array buffer, we're actually going to be using GL element array buffer this time. So I'm just going to copy and paste this all over. And again, we're going to be using static draw. So to create an index buffer, we're going to be calling this in our init function. Also, I have to create a global ID for this then. So I'm just going to copy this and call it GL index buffer ID. Okay. So now if I go to our init function, I can set the global index buffer ID to create index buffer. Okay, so now that we have the index buffer, we can go to our draw triangle function and bind the index buffer in here. So GL bind buffer GL element array buffer to the G index buffer ID. And before I forget, I should also unbind this. And now, instead of GL draw arrays, if we try to draw with indices, we need to make a call to GL draw elements. In here, we're gonna be drawing triangles again. And the count will be again the number of vertices, so 6. And the type of the data in the index buffer will be unsigned integer, so GL unsigned int, and we can just pass the null pointer in the last parameter. So I can just comment the GL draw arrays out, and if I try to compile this, we again get a nice quad. So this works now just fine, but before we actually end this episode, we should also delete all of the buffers that we created. So GL delete buffer,